Hello students, today we'll take up complex numbers and this is a calculator set. Question 1. If z is equal to 1 plus I divided by root 2, where I is the square root of minus 1, what is the value of z squared? So we can write z squared as 1 plus I divided by root 2 multiplied by 1 plus I divided by root 2, which becomes 1 plus I the whole squared divided by 2. And using the formula a plus b the whole squared is a squared plus b squared plus 2ab, we'll get 1 square plus I square plus 2 times 1 times I, this whole divided by 2. Now 1 square is 1 and I square is negative 1 since I is the square root of minus 1, plus 2I divided by 2. 1 and minus 1 goes and 2I divided by 2 is simply I. And so the square of z is option A. Question 2. The polynomial f of x is equal to ax squared plus bx plus c and it has real coefficients. F of 2I is 0 and f of 2 plus I is 7 plus 4I, where I is square root of minus 1. What is a plus b plus c? So let's first use f of 2I equal to 0 to get some values. So what will f of 2I be? It would be a times 2I the whole squared plus b times 2I plus c, and that is 0. 2I the whole squared would be minus 4. So this is minus 4a plus 2bi plus c is 0. If we separate the real and imaginary parts, we can say minus 4a plus c, that's the real part, plus 2bi, that's the imaginary part, is 0. Now, in a complex number, when the complex number is 0, it means that the real part is 0 and the imaginary part is also 0, which means that minus 4a plus c is 0 and 2b is 0, which tells me that b is 0. So I already know the value of b. Let's use the other equation. f2 plus I is 7 plus 4I. So that will be a times 2 plus I whole squared plus b times 2 plus I plus c. So a times 4 plus I squared plus 4I plus 2b plus bi plus c. In fact, we can ignore this part, right? Because we know that b is 0. So this part is something that we can simply not consider. So that's a times 4 minus 1 plus 4i plus c. So that's 4 minus 1, 3, 3a plus 4ai plus c. And if I bring the real parts together, 3a plus c and imaginary is 4ai. And this is given as 7 plus 4i. Now, this clearly tells me that 4a has to be equal to 4 because the imaginary part on the left is 4ai, now the right is 4i. So a is 1. Now, if a is 1, then 3 plus c should be 7. So c should be 4. And you can see here that it also satisfies this equation. Minus 4a would be minus 4 plus 4, and that's 0. So I have all the three values. So what is a plus b plus c? It will be 5. Option B.